Hello, and welcome to Ag Week 2021. This year, in honor of our 10th anniversary, we are highlighting innovative advancements, ideas, and individuals that have contributed to agriculture over the past 10 years in a series of 5 interviews. While we wish that these speakers could be with us on campus celebrating all that Purdue has to offer, we are thankful for their contributions to this year's Ag Week. So, without further ado, here are our presidential dialogues.
Well, hello everyone, and welcome to the Presidential Dialogue interview with Dr. Phil Nelson. We are extremely excited to have him with us today. I'm Chaela Miner, a senior on Ag Week Task Force, double majoring in Agricultural Systems Management and Agribusiness Management. To start things off today, I would like to ask Dr. Nelson to just give a quick introduction of yourself as well as a little background of the work that you have done.
Well, thank you for inviting me for this dialogue. It brings back a lot of memories. Obviously, I'm quite a boiler fan. I taught at Purdue for 50 years and even got my PhD there. And usually people leave after their degree is obtained at a university, but in my case, never got away. And of course, I had a very interesting and exciting career and was with Purdue then for those 50 years.
Awesome. Well, we're really excited to have you here with us today. So some call you the father of the food science here at Purdue. When you started your career in the horticulture department researching tomatoes, did you have a vision for what the future of the food science department would look like, or did that vision come later?
It's quite interesting. When I went back to Purdue, I got my BS and left for 4 years, and then came back to Purdue. Our family had a tomato canning plant, and so when I came back to Purdue, I was first admitted to the vet school, but saw a horticulture professor before the semester began, and before I left his office, I had an assistantship, and all of a sudden I'm in the food science area. It was hard for me to believe that what would evolve at Purdue eventually. I kept hoping that we would get a curriculum that would be across departments, and we did. With Dr. Bernie Liska, we formed a Food Science Institute. It cut across departments. We didn't have any budget or any building, but we were able to put together a curriculum that resembled a food science curriculum. There are 42 food science departments across the country, mostly in land-grant colleges. And so our institute went on until we formed the department in 1983.
Wow, that's quite cool. So much of your research was on the topic of aseptic processing. Could you briefly explain what aseptic processing is and its role in reducing food waste?
Sure. I think you'd be familiar with canning. Mm-hmm. You put the food into the container and then you close it and then you cook it in the container or heat it in the container. The difference with aseptic processing is that we sterilize the containers separately. We sterilize the foods separately, and then we put them together in a sterile environment. What that allows us to do is to heat the food in a thin film, and therefore we don't lose flavor or nutrition, and allows us to use many different kinds of packages. So it's like a heating process, but the heating is done outside of the can.
That's really interesting. Have there been any further innovations within the aseptic processing that has really surprised you?
Well, there are continual innovations occurring, of course. Probably the most significant in aseptic processing has been the package size, the package shape, the package unit has changed a lot. We're also developing new ways of sterilizing the package, sterilizing the equipment so that we can put the food together into that package. Those are probably the main things. there are over probably 23, 25 equipment manufacturers that make aseptic processing equipment. Most of them are outside of the US because it really began outside of the US before we were allowed to use the process in 1982.
Is it still primarily more popular outside of the United States, or are we seeing it here more frequently now?
It's much more popular outside of the US. You know, we developed a cold chain so we could move things across the country under refrigeration. But in countries like the Far East, China, and other countries there, they don't have that cold chain. So they're really expanding aseptic processing so they can deliver their product. It doesn't require refrigeration and therefore can be distributed throughout the vast countryside of those countries.
Interesting. Yeah, that makes sense. So aside from aseptic processing, what other advancements have you really seen within the past 10 years within the food science that you would say is the most significant?
Probably the most recent that's making headway into the consumer market is a technique we call high pressure processing. We can put the food in the container and then expose it to a very, very high pressure. That will destroy the harmful microorganisms and probably give us an extended shelf life of at least 10 times. I think we're going to see more of that in the future. So that's one. The cool plasma technology is a method of using electrical impulses to produce a plasma, which in addition will kill microorganisms. So that one is not commercial yet, but I think we will see that one coming into the marketplace.
Yeah, do you see that as the next big food innovation, or are there others that are also approaching?
Well, there are obviously others that are still in research and development. Pulse electric field is one that destroys microorganisms. Irradiation, we may see that come back. I think we'll be seeing that in the future. There are others out there, but really in the very infant stage.
Gotcha. What challenges in the next 10 years do you think really need to be overcome in this industry, and how will those innovations really help to overcome those?
Well, as you probably have read, by 2050, we will have about 9 billion people in the world. And of course, feeding those means that agriculture has to double. One thing that food science has an input in is to reduce food losses. In parts of Africa, maybe 30 to 40% of the food is lost before it even gets to the consumer. So that's on-farm losses. And so this is a big emphasis that we, the UN, FAO, is beginning to make to develop techniques, appropriate technology that will help these small farmers to reduce their food losses and, of course, increase the production of agriculture.
Interesting. Yeah, so now kind of transitioning from the food science, let's talk a little bit about your career. And as we know, failure is a part of innovation. Can you share a time that maybe you have failed and what you've learned from that and how you overcame it?
Oh, there are probably a lot of failures I could tell you about, but one that was probably the most significant was with my development of the aseptic bulk storage technology. We had done as much as we could to do in the laboratory. And so with an industry partner, we were able to scale up these large aseptic packages to a 15,000 gallon tank. This was in Pennsylvania with a tomato processor. And one summer we filled those there were two tanks, we filled both of them with pizza sauce, 30,000 gallons. In October, I get a call and say, Dr. Nelson, I'm sorry to tell you, but they've all spoiled. And so that was the biggest failure I think that I ever had. Fortunately, we'd kept good records. We went back and pored over the records, and we found that there was one place where the temperature dropped just for a few seconds and then came back, and we thought that temperature drop wouldn't make us have any problem or spoilage, but obviously it did. We came back the next year, we filled the tanks, and we were successful.
Wow. Well, that's great that you were able to come back and be successful, but it's insane that little short stint of temperature drop really made that big of an impact. Wow.
Big impact.
Yeah. So perseverance is something that you have had spades over in your career. Can you give us students some advice how you persevere even when it's hard?
Well, I think in this case, my technology of the bulk storage I really had to be passionate. I had to be determined. I had to be flexible. I had to look for resources outside of the conventional funding sources. So I think being positive, and of course, as I always tell my students, that failure is not the falling down, but the staying down. And so while there were some failures along the way, got out, brushed yourself off and said, no, I can't let this happen. And so I went ahead and really managed to develop a technology that has impacted the world.
Yeah, that's really good advice and insight, especially for students. And I think this COVID-19 pandemic has certainly caused some challenges for students. So thank you for sharing that and how to continue persevering through all this.
Yeah, and that's as simple as failing on an exam, thinking, well, it's all over, I can't do this anymore. Failure is not the falling down, but the staying down. So you got to get up and go at it again.
Yeah. I know I've certainly felt that way with some exams.
Yes.
So as you may know, this year's Ag Week, we are reflecting and celebrating the advancements of agriculture over the past 10 years. As you kind of look forward in your area of expertise, how can we continue to innovate to overcome the emerging challenges that are continuing to face our industry and our world today?
Well, there are a number of technologies out there, and of course, in terms of agriculture, I have to mention GMOs and gene editing as technologies that's going to really have an impact on the production of agriculture. Of course, food science now has to do their part in preventing food losses, and so there's all kinds of new technologies out there. Certainly, having 3D printing is a technology that's coming along. It's a way of layering the quality of a food product and making it to what you want. It's hard to describe, but that's how it is put together. There's also certainly the plant protein use will be an exciting use that will be developing more and more. We're going to be seeing more plant proteins being incorporated into our food supply.
Yeah, for sure. We're already seeing a lot of that, and I agree. I believe that will definitely continue to be big in our industry.
Yeah, sure will.
Well, thank you for your time today and for joining us for the Presidential Dialogue. It was really great to meet you and chat with you a little bit about your expertise within food science.
That's great, and good luck to you, and good luck to the students as they develop their future.
Thank you very much.
Thank you.
Thank you so much for tuning into our podcast today, and thank you to all of our sponsors for making Ag Week 2021 possible. Make sure to check out other episodes of our podcast posted throughout the week.